Hi guys, welcome back to class. We want to start looking at the very solutions of differential equation. Guys, please, for maximum understanding, ensure that you do not skip any part of this video. Yes, I mean it. Do not skip any part of this video, and ensure also that you avoid distraction. Take your time to watch this video at your closest, or even while you are in your studying table, all right, so that you will be able to maximize every principles and boundary conditions that will be given to you in the course of this training. Now listen carefully, guys. On the board, we have taken the first aspect of the methods used in finding solutions to first order differential equation, and we said by direct integration. Of course, you know, an integration is a topic in mathematics. In fact, not just general mathematics, calculus, right? Yes, it's a calculus, a topic in calculus that threatens so many students. Yes, so many students are always scared when it comes to integration. But I want to make it simple to you and see how we can go through. Now, one of the things I want you to understand is that before you can provide solution to every first order differential equation, you must end up your solution by integration of those methods. So, in first order differential equation, all you do to be able to provide the necessary solution is to integrate. It's just that you have to do other things in other methods before you get to a level where you can integrate. Alright, now at this point, by direct integration, questions that should be solved by direct integration should come in this form. Then I will explain what form is this and what form do we have on the board. What form? Now listen carefully, guys. Now, first order differential equation solution by direct integration comes in such a way that the y over the x is a function of x. What I mean now is that in such a question, you don't have y attached to the question. The only y you have there is the y. That is the only y function that you see in equation, differential equation that you solve using direct integration. I will take it again. That direct integration is said to be used in first order differential equation where the y over the x is just equal to a function of x. There is no mix up with y. There is no y anywhere. And the only place where you can find y is this the y. So now, example, we have question number 1 on the board. We are asked to solve the y over the x is equal to 12x squared plus 6x minus 5. So looking at this question as a whole, you will discover that this question is a function of x. At the right hand side here, we only have x there. We do not have a mix up with y. There is no y here anywhere to be found here. And we have it that the only place where you have y here is just the y. Are you there now? Which makes this question to be first order differential equation. Right? Now, listen carefully, guys. At this point, all I need to do is, this is my solution, is I'm going to have the y over the x is equal to 12x squared plus 6x minus 5. And at this point, to be able to solve this equation, all I need to have find out that there is no mixture of y here, only x function. I just cross multiply. So that this the x, we have relationship with all these x function, and y will be all alone. Understand that in first order differential equation, before you will be able to integrate, you need to separate x from y. Yes. How do I remove this? I simply just cross multiply, right? So I will cross multiply. I'll therefore have the y will be equal to, when I multiply this by this, I'm going to have 12x squared plus 6x minus 5. All multiplied by the x, because this dx will multiply everything at the right hand side. Then the next thing I do is to quickly introduce my integral. Guys, this is the sign of integral which you use to integrate any function, right? So I introduce my integral to both the left hand side and the right hand side. Then I have integral of 12x squared plus 6x minus 5 all the x. Now the next thing I'm going to do is if I differentiate 1 with respect to y, I'm going to have what? Yes. So understand that this is integral of 1 dy. I'm going to be integrating this 1 here as a coefficient with respect to y. So when I integrate 1 with respect to y, I am going to have y here. And when I integrate 12s squared with respect to s, guys, I'm going to have 12s raised to power 3 over 3. Understand that in integration, you increase the power of s. But for differentiation, you reduce the power of s by 1. And integration, you increase the power of s by 1. So we will add 1 to this original power to make it 3. And now divide the function by the new power. Are you there? Yes. Or we haven't increased the power of x by 1. Now divide the whole function by that new power. This is it. Then plus the next function. We want to integrate 6x. So this is 6x. Understand that 6x is 6s raised to power 1, right? Yes. So if I add 1 to this existing one here, I'm going to have 2. So I now have 2. Then I will divide the function by the new power, which happens to be 2. Then every time you integrate a constant, you introduce an x. Now we are integrating 5 with respect to x. Just as when we integrated 1 dy just now, we now have 1y. Just the same way, if I have 5 dy, I'm going to have 5y. If I have 10 dy, I'm going to have 10y if I integrate this. So the same way, if you integrate 5 with respect to x, you are going to have 5x. So I will now have 5x. And understand that in integration, after you are done integrating, or when you have successfully removed your integral, you need to add a constant. It's as simple as that. Then finally, we cancel out if there is possibility of reducing the function that we have. Of course, there is. So we're going to have y is equal to 3 into 12, guys. We have 4s cubed plus 2 into 6. We have 3s squared minus 5x plus c. This is the answer to this very question. Number 1, but other direct integration. Guys, you see, this is very, very simple. Very, very simple. Now, we are going to start looking at question number 2 very, very quickly. But guys, I want to remind you of something that we explained earlier. We said that in first order differential equation, we integrate to get the final answer, and such answer must be a function of x and y. Now, the reason why we are providing solution to differential equation is for us to eliminate the derivatives, which is the y over the x or d square y over the x square, as the case may be, depending on the order of differentiation. Your answer must be in terms of x and y only. Of course, you know that this is the integration constant, all right, which you must introduce to any function you integrate. It's a must that you add a constant. Now, we are asked to solve x, the y over the x is equal to 5s squared plus 6. Now, guys, the first thing you are quickly going to do here before you will solve is we identify whether this is first order or second order. Of course, you already know that this is first order, and now we are treating first order, so there's no need for assessing that. Now, we put down our solution, and we were given that y x dy over dx is equal to 5s cubed plus 6. Guys, this is a very simple case to look at. Very simple. Now, the first thing you must do here is, now, at this point, listen carefully. We will see that the y over dx has a coefficient. The first thing you must do is to remove the coefficient of the y over dx. Ensure that the coefficient of the y over dx is 1 before you can take any other steps. So what do we do here? We will first of all divide both sides by x. So when we divide both sides by x, we're going to have the y over dx is equal to 5x raised to power 3 over x plus 6 over x. So we just divided both the left hand side and the right hand side by the coefficient of the y over the x. Now that you have this done, the next thing you are going to do is to simplify if it is possible to reduce this function. Then we are going to have the y over the x is equal to 5. S go into s square, we are going to have s square right? Then plus 6 over x. It's as simple as this. Now the next thing we are quickly going to check for is at the left hand side we have the y over dx, and at the right hand side we have a function of x. So the only place where we have y there is the y over dx, and if this is your testimony, then you will apply direct integration method. It's as simple as that. So you use direct integration method when you have all function of x, and the only place where you have y is just the y. All we need to do here, now that we have identified that this function looks exactly like this, that at the right hand side the only function we have there is a function of x, and at the left hand side we just have the y over the x. All we need to do is to cross multiply, and when we cross multiply we are going to have the y is equal to 5x plus 6 over this dx. We just use separate x from y by cross multiplication, so this will come and multiply all the functions here. Next is to introduce our integral so that we can integrate. Then we introduce dy is equal to integral of 5x squared plus 6 over x all dx. Now guys, when you integrate y dy, you are going to have y. Yes, when you integrate 1 dy, you are going to have y. So this will have given us y. When you integrate 5x squared, you are going to have 5x cubed. Understand that you must increase the power by 1 all over the new power. Then plus, now guys, there is something you must understand here. Please, if you do not understand some major standard integrals in integration, please, you need to go to your textbook and see how you can get that done, or wait for our next session of video on integration. Right? So if you integrate a over s, guys, you are going to have a ln x. Is a standard. So when I integrate 6, now look at it. What I mean, like if you integrate 6 over x dx. Now this is a fraction, and we have the variable at the denominator, and at the numerator we do not have the variable. So and the denominator, listen now, at the denominator the power of x there is 1. So since the power of x here is 1, therefore guys, all we simply need to do here is to use any of the standards. So when you integrate 6 over x, you have 6 ln x. That's all. It's as simple as that. It's as simple as what we have here. When you integrate 6 over x, you have 6 ln x. Because the power of x at the denominator is 1. So there are conditions I'm going to give you as we progress in the course of this tutorial class, right? Now we are going to solve last question under this segment, question number 3, because all the questions are solved in the same way, similar ways, right? So we are going to look at one more question before we veer into integration by separating the variable. All right, we have question number 3 on the board. Now we are asked to solve s squared dy over dx is equal to 2s raised to the power 4 plus 3x raised to the power of 3 minus 5. Guys, so this is what we had, and then we put down the question. Dy over dx is equal to 2s raised to the power 4 plus 3x raised to the power 3 minus 5. Guys, all we simply need to do here now is to first make the coefficient of dy over dx 1. And how do we have that done? We simply divide both sides by the coefficient of dy over dx, which happens to be s squared. So when we divide both sides by dy over dx, when we divide both sides by s squared, we are going to have dy over dx is equal to 2s raised to the power 4 over s squared plus 3s raised to the power 3 over x squared minus 5 over s squared. It's as simple as this. Then the next thing we do is to see how we can reduce this equation. Then we are going to have dy over dx is equal to this into this guy. We are going to have 2s squared. S squared will go into s raised to power 4 to reduce it to s raised to power 2. Then plus 3s raised to power 1. If you remove 2 from 3, you are going to have 1. Here, if you remove 2 from 2, if you remove 2 from 4, you are going to have 2. Then, at this point, we're going to have this as nothing can go s squared. So the next thing we are quickly going to do is to identify whether this equation can be solved with the first method, which is what? By direct integration. Like we said, there is a condition to know whether any particular differential equation can be solved using direct integration. What are the criteria? That the only place where you will have y function is the y. And at the right hand side of the equation, only s should be the variables there, right? Now, only s should be the variable there. Now, when we look at this now, we have this right hand side as just a function of x. So what else we do is just to introduce, is just a what? Make the y the solid formula. That's all. By taking the s to multiply the functions of x. Therefore, we are going to have the y is equal to 2x squared plus 3x minus 5 over x squared, all multiplied by the x. Now, at this point, now that we have successfully separated y from x, we now need to introduce our integrals so that we can integrate these functions with respect to their respective variable, right? So at this point, I'm going to have integral of dy equal to integral of open bracket 2x raised to power 2 plus 3x minus 5 over x all dx. So guys, at this point now, where we are, we see that we have a fraction. So there are two things you will always do when you have this fraction. Please listen to this. If you have 5 over x and have 5 over s raised to power 2, they are not the same. The way you treat 5 over x is different from the way you are going to treat 5 over s squared. Of course, somebody will say, okay, since the power vary of yes, it varies. That is one of it. But the same way you are going to treat this is the same way you are going to treat 5 raised to power l raised to power 3, 5 raised to 5 over s raised to power 4, 5 raised to power s raised to power 5. The same way you will treat this. Now, what is the condition? When you have your variable at the denominator and the power of the variable is 1, when you integrate, you have the numerator limit of the denominator. But when you have the power of the variable at the denominator greater than 1, you cannot integrate it with this method. All you need to do is to convert it to a linear function. What do? You're going to have 5s raised to power minus 2, or 5s raised to power minus 3, or 5s raised to power minus 4, or 5s raised to power minus 5, just like that. This is how you are going to solve this aspect of integration. So when we look at the question we have now, we see that at the denominator of that fraction, the power of s is more than 1. So it's not going to be a lead function when we integrate, right? So we are going to use this method. First of all, use the fourth law of indices to convert it to what? A linear function. And that's exactly what we are going to do now before we integrate. Then when we still push down this, we have the y over the x. We have the y is equal to integral of 2x squared plus 3x minus 5x raised to power minus 2 all dx. Yes. Now guys, what's the next thing that we're quickly going to do here? At this point, when we integrate 1 dy, we are going to have y. When we integrate 2s squared, guys, you are going to increase that power by 1, which will now turn to 2s raised to power 3. Then we have 2x. When we add 1 to this, it becomes 3 all over what? 3. Because that is the new power. You will now divide that particular function by the new power. Then plus 3 s raised to power 1. When we add 1 to 1, it becomes 2. So the power increases to 2. Then we now divide everything by 2 again. Then minus. Now understand that this will have given us 5 s raised to power minus 2 plus 1. Now we add 1 to this to give us 3. We added 1 to this to give us 2. Now we are going to add 1 to this. Now minus 2 plus 1, guys, you are going to have minus 1, right? So we are going to have this as y is equal to 2s cubed over 3 plus 3 over 2s here minus 5 s raised to power minus 1. Minus 2 plus 1 will give you that. Now, understand that this is going to be what? All over what? The new power. Alright, yes. It's going to be all over the new power. Then the next thing we are going to have is that y is equal to 2 over 3 s cubed plus 3 over 2 s squared minus 5 s raised to power minus 1 over minus 1. This is what we have at the denominator and at the numerator. Now the next thing we are quickly going to do is to have this as 2 over 3 s raised to power 3 plus 3 over 2 s raised to power 2. Now minus divided by minus, this will turn plus, guys. Then all over what? 5 over x plus c. This is our answer to this particular question on the board. It's as simple as this. Very simple. So simple. So when you just integrate, you have this. Understand that this divided by this is this, and s raised to power minus 1 is equal to 1 over x. This is as simple as this. So see you guys in the next aspect, where we'll be looking at first order differential equation by separating the variables. Guys, if you have not subscribed to this YouTube channel, ensure that you subscribe before you exit this particular video you are watching, and ensure also you like this current video you just watched. Please turn on the notification bell so that anytime we upload my brain content, you will be notified. Of course, on daily basis, we'll be releasing content. Alright? Now, when you check the description below, guys, you are going to find the link to the next video. See you guys